All right, let's do the extra question for assignment 1. So not strictly necessary, but it does help you understand, make sure you understand everything in the polyfit function. So I've copied the question down into the comments here. It says, um, it's supposed to say, assuming that gravity is 9.81 meters per second squared, can you estimate the initial velocity, the initial height, and the angle of the projectile from the data given in the data? How are you going to do that? So you should go back to equation 1 and think about it again. But basically, we've got already from the last question, task 6, we've got P1, P2, and P3. These things are all related to the initial velocity, which is v0, let's call that v4, the initial velocity, v4, the initial height and angle, everything. So what we'll do, we're going to bring this down. I'm going to think about this some more. So this is more maths, I would say. So we've got this vector p from the data, right? By doing polyfit, this vector here. P1, P2, P3. So let's have a look. So what we have is that P3 equals the initial height. So all we have to do is reverse who equals who and put the initial height, we're going to call that y4, equals P3. So that's it. That's the first part. The question, it says estimate the initial height. We've done that. So yeah, next we're going to get the angle from this second equation here. So here we have that P2 is the tan of this angle, right? So what we really want is we want to find out this angle. So what you want to do is you want to apply what's called the arctan to both sides of this equation. So again, you should go to the MATLAB help. Let's go there. Let's write arctan. Is that going to work? Here we go. Atan 2. No, that's different. That gives you the arctan from y and b. We want to, given the angle, to give us the tangent. So the function is called atan. Atan, if you give it the angle, it will give you, if you give it the tangent, sorry, it'll give you what the angle was. You can read it out. So that's it. I'll let you read that documentation in more detail. I'll just show you what it does. So if you apply atan to both sides of this equation, now this, I'm just using this as a shorthand for maths. This doesn't work in code yet, okay? You can't run this yet. What it will do is that this function is the inverse of that one, and so on the right it will just become theta. Now you need to reverse you need to put theta on the left side, because in coding, equations means that the left thing gets equal to the right thing. So in maths, it doesn't matter which one's which, right? If this is on the left or right, but it does make a difference in coding. So that's it. That's the bit we needed there, just that there. So now we already have theta 4. We already have the angle theta, and we already have the initial height. So finally, what we want is we want the initial velocity. So again, I'm going to manipulate this as if it's an equation, okay? But remember, in coding, you can't run this. This won't be right, because v4 is not defined, and it'll try to calculate what this is. So we're going to need to reorganize this to get v4 on the left. All right, let's do it. So first of all, I'm going to multiply both sides of the equation by this thing here to take it off from the bottom of a fraction, to bring it on the top. Then I'm going to divide both sides by p of 1. There we go. Let me remove this star here. Now I've still got this v4. I'm going to distribute this square. So the square, the power of 2, the square of two things multiplied is the square of the first times the square of the second. Hopefully you can understand that I'm just manipulating this as if it's maths. Now I want just to have v4 on the left, so I'm going to divide by this. So I need to put this both p1 and the cosine square divided. Finally, I have that this is squared, so I need to take the square root on both sides. You can do that on pen and paper, okay? I think a lot more people feel comfortable doing that on pen and paper and then writing it into code. I've just done it all in one go here, so don't you mind me. So now we've got G defined, we have P1. There's a negative here. Should we be worried that there's a negative within a square root? What do you think? It depends on the sign of P1, doesn't it? Have we already got that printed? We do. Look, P1's negative. So a negative with a negative, it's positive, not to worry. Okay, and that's everything. That gives you the initial height. So we can put a comment here. Initial height. Initial angle of launch. Launch. And initial velocity. Velocity, all calculated from the data. So now you could go back and use the formulas for y and x or d with these values for the initial projectile, and you could check if your answer works. Just like that. So that completes the extra challenge.